Dear aspirants, welcome to my channel. This is a model question paper 2, applied electronics. So remaining question, explain why heat sink is used with a BJT transistor, bipolar junction transistor, how it prevents thermal runaway. Okay, heat sink in the BJT. What is heat sink? Heat sink is a metallic device. It is attached to the transistor. It will be remove excess of heat during a operation. That we call it as an heat sink. Okay, it is a metallic device. It has attached to the transistor. It remove excess of heat from the operation during operation, and it is made up of aluminum because aluminum having a good conductor of heat. This heat sink which we can use for BJT, it will remove excess of heat generated during operation and keep the transistor temperature under control and prevent thermal runaway. Okay, during operation which will be BJT will be produce heat due to power dissipation. If heat is removed, what will happen? If heat is removed, what will happen? So junction temperature will be increases, collector current is increases, transistor may get damaged. Therefore, heat sink used to dissipate the heat, okay, safely. So, how heat sink prevent the thermal runaway? So, heat sink will absorb heat from the transistor. It transfer heat to surrounding air. It transfer the heat surrounding air. In the junction temperature remains with a safe limits, within safe limits. The collector current remaining stable, it will be remaining stable, prevent excess of heat and transistor damage. Next question, describe how CE amplifier achieves voltage amplification compared to CC and CB configuration. In that CE amplifier voltage amplification, CE is a common emitter amplifiers mainly used for voltage amplification. We can use it for voltage amplification. Input signal, whatever input signal applied between the base and emitter terminals. Okay, the output taken by the collector and emitter terminals. Okay. A small changes in a base current because cause the large changes in the collector current. Same way large collector current flows through the collector resistor will produce the large output voltage. Based on this, CE amplifier will give high voltage gain and high current gain. So in the CC configuration, if the voltage gain nearly equal to 1, so it is not suitable for voltage amplification. Same way, CB configuration, if the voltage gain high because current gain less than 1, therefore CE configuration prefer because it provides both high voltage gain and good power gain. And next question, describes the construction and operation of RC coupled amplifier. Explain why multi-stage coupling prefer for high voltage gain. RC coupled amplifier, coming to the construction, the name only indicate RC coupled amplifier, it consists of 2 or more CE amplifier stages to be connected together. Okay, when output in one stage connected to input, for the output is connected to one stage and input is connected to next stage through the couple capacitors. Okay, their name only indicated, and it also connected to resistors are used for reverse biasing and collector load each stage. This couple capacitor blocks DC, allow only AC signal passes. Coming to an operation, when AC signal applies to the first stage get amplified. Amplified output passes to next stage through a couple capacitor. The second stage of amplification, it will gain the signal. Okay, and each stage increase the signal strength which will be produce a large amplified output. Why multi-stage coupling output we are preferring? In the single stage, it will give a limited voltage gain. If you use a multi-stage coupled amplifiers or coupling, we can use, it will give output one stage become input, the next stage input, next stage overall voltage will be increases more. And RC coupled, it will be provide a good audio frequency response and compared to simple circuit design. Therefore, couple multi amplifiers are widely used for high voltage amplification. In the audio amplification also we are using. The next question is, in N junction, in N channel JFET, explain how drain current changes to gate to source voltage. So coming to the drain current variations in N channel JFET, the first point is, in the N channel JFET is made up of N type of semiconductor through a electrons flow through from source of drain. In the gate to source voltage VGS, which will be controlled by drain current ID. When VGS is 0, the channel fully open, the maximum dry current flows. The current called as this current called as ID is equal to IDSS. When negative gate source, the voltage applied, then a depletion region around the gate it will be increased. Due to the channel wide width is decreases, drain current is reduces. So VGS become more negative, the drain current decreases again further. At a particular negative voltage we call it as a pinch off voltage, that we call it as VP, the channel closes completely. At this condition, the drain current become near zero. Thus, N channel JFED drain current decreases as gate source voltage become more negative. If the content is useful, please subscribe my channel, share and support. Remaining Model 3 question paper I am going to upload next video. Thank you.